Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So this is another lecture from the Strivers A to Z DSA course. Just in case you're for the first time here, this is world's most in-depth course when it comes to DS Algo. Why do I say that? 455 modules. By the end of the course, you would have solved more than 400 plus problems in DS Algo. You can go across the entire internet. You can buy any of the paid courses. None of them will be teaching you DS Algo in such depth. Something that I can give you as guarantee is, once you complete this entire course, you can clear any of the DS Algo rounds in any company, in any part of the world. So till now we have covered till this particular problem. Now in this video, I'll be covering the problem set matrix zeros. Now what does the problem state? The problem states you will be given an n cross m matrix. N and m can be different, can be equal. Now the matrix only has 0 and 1s. That means it's a binary matrix. Your task is to find out zeros. Once you have figured out zeros, so there is a 0 over here. What you do is, you go to the entire column in which that 0 exists. You go to the entire row and you mark every one as 0. You mark every one as 0. Done. Where is the next 0? Here. So you go entire column, entire row, and you mark every one as 0. Done. Next, where's the next 0? Over here. So you go across the entire column and row and mark every one as 0. Now remember one thing, over here there's a catch. If there's a 0 here, you go here, mark here, mark here, mark here, mark here. But from this marked zeros, you do not do anything. Only whatever zeros are there during the initial time, for those zeros you go for the rows and columns. For those zeros you go for the rows and columns. Nothing apart from them. Got it? So this question comes up in an interview. The first solution that you'll give to the interviewer should be of the brute force solution. Now, what is the brute force solution that you can think of? Let's do whatever is being told to us. What is being told to us? If there's a 0, go across the entire column, mark everything as 0. And go across the entire row and mark everyone as 0. So probably let's try doing this as the part of the brute force solution. So what we do is, we're given this n cross m matrix. We will try to iterate on it. And how do we iterate on matrix? We go like this, like this, like this, like this, and so on till here. So let's try to do it. So we start from here. It's a 1. It's a 1, it's a 1, it's a 1, it's a 1. We don't do anything when there's a 1. And we find a 0. The moment we find a 0, what was the task? Like the entire column has 0 and the entire row has 0. So what we will do is, we will go ahead and probably mark everything as 0. But is that the correct solution? Think of it. Once you've marked, the array will look something like this. And in the next step of traversal, you will reach here. And then for this 0, you'll mark everyone again as 0, right? And then you'll get this 0 and you'll start marking this. But that is a wrong solution. Because of this 0, you ended up turning this 1 to 0. And when you're traversing, you will find a 0 here and you'll end up marking everyone as 0 on this column, which is wrong. Because over here there's a 1. So these people should not be 0. So thereby, you have to be careful. You just cannot go and blindly mark everyone as 0. You cannot do that. So what I will do is, I will go through the entire column and I'll mark everyone as -1 rather. Yes, I'll mark everyone as -1. So I'll mark it as -1. I'll mark it as -1. I'll mark it as -1. Anything apart from 0, I'll just mark it as -1. Done. Let's now quickly do the next job. So this column is done. Now we will do for this row. So let's -1 and then -1. Make sure you do not mark zeros as -1 because this 0 will again be responsible for marking it. So if you mark it as -1, there will be an issue. So for this one, I've marked this, I've marked this. I'll move forward. The moment I move forward to this, we have a 0. So we'll go for this column and we'll go for this row. So let's do it. -1. Again, do not mark this, -1. And this particular row is done. Now we will start iterating. We have a -1. Thereby we will not do anything. Had we marked for this 0, 0, we would have ended up marking this, which would have been wrong. 1, -1, 0. Okay, we have a 0. So entire thing and then this entire thing. So this will be -1, rather -1, and this will be -1. Perfect. Next, this one, next this one, next this one, next this one, next this one. Once you have done this, now what do you know? For these zeros, whoever was to be marked, they have been marked -1. So let's do one piece of iteration more. Yes, let's do one piece of iteration more. And what we will do is, we'll just convert them to zeros now. We will just convert them to zeros. And once you have done this, I can say, this is my final array and this will be my brute force solution. quite simple. Just we have to be careful. It's not about doing what they have said because that might cause an issue. So thereby we will just introduce something as -1 in the brute force solution. So if I have to write the code for the brute force solution, so in order to traverse, we first traverse from 0 to n, then we traverse from 0 to m. This is how you usually traverse in a 2D matrix. And then what you do is, you say if there's a 0 on that particular place, we go to the ith row and mark that. That means this portion. Then we go to the column, that means this portion, and we mark it. And you have to write these couple of functions separately. So let's quickly write it. So the mark row function will be very simple. It takes a row number and then it iterates for the columns. And in every ij which is non-zero, do not mark the zeros. In all the non-zeros, you can just assign -1. Similarly, there will be a mark column which takes the column number and iterates for every row and marks that column as -1 if it's a non-zero. So this code will make sure that everything that is a 0, in that particular column, everything will be marked as -1. And in that particular row, everything will be marked as -1 apart from the zeros. Got it? So once you've done this, what's the next job? The next job is just to iterate in the matrix and whoever is -1, turn it into 0. So let's quickly do it. So this will be the final piece of code where we iterate in the matrix and we say if it's a -1, please convert it into 0. So what will be the time complexity of the brute force solution? Can I say over here it's n into m? And inside, can I say this is taking VGO of n and this is taking VGO of n because there are two loops that are running. So thereby, it's something like n into m into n plus m, very important, into n plus m. Plus, you're again doing an iteration of n into m in order to initialize them to zeros. So this is the overall time complexity and it's somewhere to the power of cube. Somewhere to the power of cube. If you carefully see, this and into this will be somewhere near about the power of cube. And the interviewer will not be happy with it. And he will say that this is not accepted. And that's when you move to the better solution. So let's quickly check out the better one. So we gave a brute force solution to the interviewer, which was taking a time complexity in the order of n cube. And why was it taking a time complexity in the order of n cube? Because we were traversing in the array and that was taking n square, like in the order of n square, like n into m. And then what we did was, for every 0, we went across the entire column and the entire row and we marked every one as 0. So this is where we were taking that extra time for going across the column and going across the row. So what do we need to eliminate? Because if the interviewer is asking us to optimize, the optimal solution will definitely not be n cube. We need to optimize this. And in order to optimize, we might be able to get an n square or somewhere around n square. That's for sure. This is where we need to think, what do we need to eliminate? We need to eliminate this and we need to eliminate this. How can I? Now, can I say, what was I doing? I was going across and marking everyone as 0. I will not do that. Instead of that, I'll think, for this one to be 0 in the final matrix, for this one to be 0 in the final matrix, why will it be? I'll be like, if this entire column has a minimum of 1 0, can I say, if it is a minimum of 1 0, or if this entire row has a minimum of 1 0, agreed? Because this 0 will convert this to 0, even this 0 will convert, but what I need is just 1 0. And so can I say, if there's a 0, instead of going across the entire column, I'll say if there's a 0, I will mark it. I'll mark this column because at the end of the day, everyone will be 0 in this column, that's for sure. So I'll just keep a track. This column is done and dusted. At the end of the day, everyone will be 0. Similarly, if there's a 0, this row is done and dusted. Everyone will be 0 at the end of the day. So instead of marking them at the current time, I'll say, let's probably keep a track. And by the end of the day, I will mark it. This is how my thought process will be. So to have that thought process converted into algorithm, what I'll do is, I know that for the 0, I'll have to mark it. And for the 0, I'll have to mark it. So there has to be 4 column array, correct? Which will keep a track if the column is marked. And there will be a 4 size row array, which will again keep a track if the row is marked or not. So I'll go ahead and create a m size. Yes, very important. I will create a column array of m size because those many are the number of columns. And I'll create a row array of n size. Over here, n and m are same. And what I'll do is, initially, I will mark every one of them as 0. 0 means they're yet not touched. And now I'll start iterating. First, no. 1, no, 1, no, 1, no, 1, no. You will not do anything when there's a 1. And then you go ahead and see there's a 0. So whenever there's a 0, you know this entire column is done and dusted. At the end of the day, everyone will be 0. So please go ahead and say, I will mark it. Marking it means 1. Perfect. And you know, everything in this row will also be marked. So you mark it as 1. Perfect. 1, 1, 1, 1. 0 again. 0 means everyone in this column and everyone in this row. Go ahead and mark it. So you'll mark it. Perfect. Next, 1, 1. Again a 0. This 0 means this one is marked and this one is marked. So go ahead and mark it. Perfect. Next, this 0 means this one is marked and this one is marked. Next, this done. So what I've done is, for every 0, I've ended up marking which columns and which rows will be 0. Now what I will do is, I will do a reiteration. Yes, I'll do a reiteration. So let's quickly do the reiteration. So whenever we are at 1, we are like, okay, wait, will I be a 0? I will only be a 0 if this or this is marked. Is this marked? No. Is this marked? No. So I stay 1. I stay 1. Perfect. I will say 1, I'll only be 0 if this is marked. I'm like, yes, I'm marked. So I'll end up getting 0. Perfect. Next, I have a 1. Oh, this is marked. So I'll end up getting 0. Next, 1. 1. Not marked, not marked. So stays. Next 1. Not marked, but marked here. So this will be a 0. Next, 0, nothing to do. 1 marked. So this will be a 0. Next, 1 marked. So this will be a 0. Next one marked. So this will be a 0. Next one marked. This will be a 0. 0, nothing to be done. This one marked. This will be a 0. This one marked 0. This one marked 0. This one marked 0. This one already a 0. So what we got to know was this entire thing got 0, if you carefully see, and everyone over here got 0 apart from these two elements. And this is how easily you can do it. Got it? So how will the brute force code look like? We know we need a column of size m to keep a track. So I'll mark everyone as 0. And we know we need a row size n to keep a track of everyone who's 0. Now I will start iterating. So if we have to iterate in the matrix, first I'll go from 0 to n. Then I'll go from 0 to m. Perfect. Then what is the next job? If that element at ij is 0, I know the row I will go ahead and get marked as 0, and the column j will go ahead and, marked as 1 rather. Marked as 1. Both have been marked, and this is how you can iterate and mark it. Once you have done that, you again reiterate. Yes, you again reiterate from 0 to n. And this time, you convert the 1s to 0s who are marked. You convert the 1s to 0s who are marked. So what you say is, if you are marked, if your row is marked, or your column is marked, if anyone is marked, I do not care. You will be 0 for sure, because the entire row is marked or the entire column is marked. If that's the case, you will be this, and this is how the code will look like. Got it? So in case you want to try out the problem, the link will be in the description, and if you want the C++, Java and Python code, all the links will be in the description. Remember one thing, over here they're asking us to return a matrix. That is why I'm returning. If it's a void function, then you can just change to this particular matrix, which we are doing, and we do not need to return anything. So coming back to the iPad again, what is the time complexity? Can I say this is taking bgo of n cross m, and so is this. Therefore, the time complexity is bgo of 2 cross n cross m for sure. What about the space complexity? The space complexity is nothing but bgo of n and bgo of m for the two arrays that you're using for hashing. This is where the interviewer will not be happy, because you're using an extra space, and he will ask you to optimize the better solution, and you will move to the optimal one. Over here, can you optimize the time complexity? We are already doing it in the order of n square. And we know the minimum in order to traverse a matrix can be n square. You cannot do better than that. That's why we will be focusing to optimize the time complexity. And let's get back to the matrix. We were taking a column and we were taking a row. Agreed? So if I was taking a column and if I was taking a row, if I have to optimize it, what does that mean? That means you have to do everything in the matrix itself. So what I'll start thinking is, can I keep a track in the matrix itself? Can I just probably keep a track in the matrix itself? And that's when I start thinking, what if I say, hey, maybe instead of taking a row outside, what if I consider the first column to be my row? Like instead of taking here, I moved it inside. In place, I moved it inside. So what I'm saying is, row R at the column of 0 will become my row, which I was taking. Probably yes. And now I'll say, probably instead of taking this, I'll move it inside. Maybe because I have to do it in the matrix. So that's a possible solution. The row 0 is what I will now consider as column of M size. That's my first assumption. But can I take it? Let's see if that's possible. So what am I saying? The things that I was marking here, like for this 0, if I was marking here, now instead of marking here, I'm taking this and I'll mark it here. That's what I'm saying. Correct? But is it correct? It's not correct. Why? Because, okay, I understood. You took the column inside and that's how it looks. But you took the row also inside. And now there is one single point which acts as the same. And if you remember the better approach, there was a row here and there's a column here. And everyone was individual. This point and this point were individual. But if you take them inside, what happens is, this is one and this is one. And this is a single point where it's a common point. So what I'll say is, it's about one point. Now I'll apply my brain. And I'll say, okay, probably let's keep the row as row. So I'll keep the row as row. Perfect. And the column I'll take till here. I won't take the entire column. I'll take till here. But then I'll be like, what will happen to this one? Like, who will keep the track of this? Because instead of this, what you're doing is you're just taking this. So what happens to this? I'll say, okay, this one is a single element. Now, it's a single element. Now, I will probably extend this to something like this. Can I do this? I'll call it as a column variable. I'll just call it as a column variable. Can I call this? Because this is an extra part. This is an extra part. So the row stays as row. And I take this much. And for this, since it is colliding, I put it into a variable. Now there is no collision. Works. Works fine for me at least. So now what I'll do is, I'll try to probably draw the figure. It's something like this. And then I go like this. And I go like this. Perfect. That's how the column array will look like. And it's more like, maybe I can call it as column 0 and mark it as 1. And this will be my row. Do you agree? You do, right? So this will be my row. The same brute force I'm trying to optimize. Look at the intuition. Okay. Now, let's start iterating and let's try to do the same things that we did. But before that, let's keep something in mind. This 0 will mark everything here and mark everything here. Agreed? This 0 will mark everything here and mark everything here. Agreed? This 0 will mark everything here and everything here. So if you remember, so if you see, everyone will be converted to zeros only apart from this corner guy. Keep this in mind that this corner guy will not be converted. Keep this in mind. It will be very, very useful in the next part when we figure some edge cases. Keep this in mind. The corner is not converted. Okay, let's start iterating in the matrix. We have a 1, right? What happens to this one? This one says, I'm a 1. So I do not harm anyone. Let's move. I'm a 1. I do not harm. I'm a 1. I'm a 1. I'm a 1. I do not. But he's a 0. He's like, what did I do? I'll keep a track. So I'll mark it here. I'll mark it here. And I know who is this now? This guy? Who is this? This one. So I will now go and convert them to zeros. Perfect. Next, I have a 1, 1, 1, 1, 0. This 0 was marking it here and marking it here. So instead of this, I'll mark it here. Perfect. Next, 1, 0. Now this 0 was apparently marking it here and was apparently marking it here in the column array. So what will happen now? Instead of here, it will mark here and it's already a 0. So it's okay. And instead of here, it will mark here. So this will make it 0. Perfect. Next, we have a 1, we have a 1, we have a 1. So the iteration is completed. Once the iteration is completed, what is the next job? To convert all the ones to zeros who are marked, correct? To convert all the ones who are zeros. This is where you have to remember. In the answer, only this one was not converted. So, if I'm trying to convert this, whom do I check? I check in this and I check in this, correct? For this one, I see the column 0 is 0. So this will be 0, right? Because it's marked. If you remember for this, we will check this and the column 0 is 0. So this will be converted to 0. But here comes the twist. If you convert this to 0, hypothetically just assume you converted this to 0. Now the twist is, if you convert this to 0, what will happen is, now when you go to this one, okay, this one will say, I will be converted to 0 if this is 0 or this is 0. And what will happen is, it will find here 0 and it will convert this to 0, which is wrong. Because this row means this. So thereby, you cannot start from these elements. You cannot start from these. You can keep them for later. Because as of now, if you change the values, that will impact the matrix. Do not change their values. Instead, try doing from these places. Did you understand? I hope you did, right? So what I'll do is, I will not touch them as of now. And I will start going probably from here, then to here, then to here. And then we can deal with this separately. Got it? So let's start. This one, will it be marked? No, it's a 1, but it's a 0. So this will be marked. Perfect. This one, it's a 0. It's marked. Next, this one, it's a 0. It's a 0. Mark it. Please do not do anything to the first rows and first columns. Please. Next, there's a 1. Will it be? No. Will it be? Yes. Next is already 0. Next, 0. Next, 0. Why? Because over here. Next, 0 because here. Next, 0. So what I've done is, I've converted each of them. Now it's time for the next. Okay, so the last section of this algorithm, and it's very important that you hear me out properly. So do you remember one thing? Initially, I told you this is the only one who was not converted to 0. And everyone else would be converted to 0. Now tell me one thing. You have solved this portion. Will you solve this portion at first? Or will you solve this portion at first? Let's analyze. This portion's answer is dependent on whom? One is this and the other one is this. Correct? Agreed or not? You agree? So, this one is he himself. And this one is 1. So, it's dependent on this. So, if you solve this portion at first, the value might change. Which might hamper this, which might impact this. So, at first, you will solve this portion. Then you will solve this portion. Now, for this portion to be 0, this has to be 0, which is not the case. So, this stays as 1. For this is already 0. And this is already 0. And we do not do anything else. Now, for this portion to be 0, this one has to be marked and this one has to be marked. And I see this is marked. So, this will be 0. Converted to 0. For this portion, it's 0, 0, 0. Done. So, first you solve here. Then you solve this because it is dependent on this. Then you solve this. First, do not solve this because if you change the values, that will impact the matrix. This was the thought process behind this particular algorithm. So let's quickly code the optimal solution up. And this was the better solution if you can see in the editor. So I'll probably remove this and I will just comment this off. So we were initially using a column and we were initially using a row. Now instead of column, if I go back to the iPad, instead of column, we will be using the row 0. Which is the row 0? Can I say the row 0 is this? Which is nothing but matrix of the 0. Yes, because this is 0, right? Matrix of 0 is what we will be using. So can I say the column is nothing but the matrix of 0 and something, the variable, whatever is the variable. And can I say the row is nothing but, if I carefully see, the row is nothing but the zeroth, which is matrix of something of 0 because the row keeps on changing, but this stays constant. So can I say it's nothing but matrix of something of 0. Very simple. This is the first row and this is the first column which is taken as this. Perfect. Now over here, if matrix of ij is this, what do? We mark the ith row and we mark the jth column. Now we are marking the row. Which is row? See, row is here. So we'll just take this. Let's take this. So we mark the ith row. So we'll say let's mark the ith row. So ith row is this and we will say 0. And what are we saying? Mark the jth column. Who is the jth column? This one. So we'll take this and this is the matrix, and you will say, let's mark this. But can we simply write this? The answer to that is no. Why? Because if you remember this case, it did mark itself. That is okay. But it could not mark in the column. It could not mark in the column. And if you see over here, what's the column? That's the matrix of 0 of something. Matrix of 0 of something. So remember, if J is not equal to 0, then only you mark it. Otherwise, yes. Otherwise, what will you do? You will say column of 0. Can you mark yourself? If your J is 0, let's go back again. If you are over here, you do not mark it here. Instead of you mark it here. Got it? Do not mark anything on this. Instead go here. So please go ahead and declare one more variable. Column 0 is equal to 1. Perfect. Done. So this is the marking that I've done. After the marking, what do we do? Let's analyze that. Whatever we do. So after the marking, once we marked this and this, we started from here and then we went on. So it's more like I ignored the 0th row and I ignored the 0th column. So just iterate without them. So I'll be like, I can iterate without them as well. So you can again iterate from here. That's okay. Or you can iterate from here as well. That is okay. That is your choice. So I'll go ahead and say, okay, let's iterate without them. You can iterate in the backward or frontward. That is your choice. As long as you're not touching our hash arrays, I'm absolutely okay. So what will happen? What will happen? If this is a 1, I have to convert it. The first check will be if matrix of ij is not equal to 0, then there might be a conversion. For this, I'll have to check here. For this, I'll have to check here. So check for column and row. So let's check. First, you have to check for column. What's the column? That's this. Let's pick it up. Or what's the row? That's this. Sorry, that's this. Let's pick it up. So I picked up. So over here, instead of this, you will have a J. Over here, instead of this, you'll have a I. And if any of them is marked as 0, that means this element will go as 0. Quite simple. Simple. Done. Second step done, where we have marked everything. After that, what did we do? First, we marked these 3 elements. Then we marked this. So how will this 3 elements, when will this 3 elements be 0? When will this 3 elements be 0? If this guy who has matrix of 0, 0, if this is 0, then everyone will be, because it's dependent on this. So the last step will be, hey, if matrix of 0, 0 is equal to 0, everyone in the column, which is this matrix of 0, j, everyone in the first row will be 0. Quite simple. And what about this one? This one will be dependent on the column. So please go ahead and say, if column 0 is equal to 0, what will I do? I will do the same thing for I and I equal to 0, I lesser than n, I plus plus, because everyone on this portion will be marked as 0. So I will go and say matrix of matrix of I, and everything on the first column will be 0. Once you have done this, you can return the matrix. Now let's quickly go and run. I hope it runs at once. I'll be super happy. Oh, I am. Quite simple. The only way that you can write this is try to write this so that you don't get confused. This is how I approach usually a code. So what is the time complexity? N into M. And this overall is the total matrix iteration, N into M. 2 into N into M. Are we using any extra space? Probably yes for this column. One variable. That's it. One variable, and I was able to solve the problem in place within the matrix itself. So let's go back to the sheet and mark this as done. I hope you have understood all the 3 approaches and the build up to the optimal solution. Just in case you did, please do consider giving that like, because it won't cost you anything, but it will highly motivate me to make these kind of content. And if you're new to our channel, what are you waiting for? There's a bunch of content on our channel. Please do consider subscribing to us. And yes, to continue our tradition, please do comment understood. And if you haven't followed me on Instagram, Twitter, LinkedIn, the links are in the description. With this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye-bye. Take care.
Whenever your heart is broken, don't ever